A subsea pipeline, also known as offshore pipeline, is a length of pipe that is laid on or below the seabed. It is used to transport oil or gas across long distances. Under the dark bottom of the sea, there exists an extensive network of subsea pipelines. For reference, this is a map of subsea pipeline network in Europe. In this video, we'll break it down and see what is inside the network. Let's begin with the most possible simplified perspective before looking into the more complex aspects. This is a wellhead where oil or gas comes out from the ground. The pipelines that transport the oil or gas to the processing facilities onshore or offshore are flow lines, also known as production pipelines or infield pipelines. Export pipelines are responsible for transporting processed oil or gas from the production platform to onshore and offshore facilities. Transmission pipelines carry oil or gas from one coast to another, primarily for trading purposes. Now, that's way too simple to look at the subsea pipelines. In reality, there's no such thing as one straight pipeline that would handle everything. It actually involves a comprehensive system. Let's start again from the well, where oil comes out. When a newly discovered reservoir is tapped, oil flows out under an extremely high pressure. A subsea tree is installed. It regulates pressure and controls the flow of oils. A jumper. It connects and transmits oil from the subsea tree to a production manifold. In this setting, there are 6 wells. The production manifold. It collects and directs fluids from multiple wells into one or more flow lines. The PLET. It serves as the connection point between 2 pipes. PLEM. Similar to PLET, but it can connect and distribute the flow from more than 2 pipelines. A subsea boosting pump may be installed. When a reservoir has low energy or insufficient pressure, a pump station can be utilized to increase the flow rate. From here, the flow lines are connected to vertical pipes known as risers and transporting oil up to the production platform. All of these machines require power to function. If not, they are just a bunch of useless metals under the bottom of the sea. To provide power to these equipment, a large cable known as an umbilical is installed. Inside the umbilical, there are several components that serve different functions: high voltage cables, electric cables, fiber optic cables, chemical fluid lines, and a hydraulic fluid line. The umbilical is connected to a SUTA and then connects to the SDU and then distributes the cables to the rest of the subsea system. This is only the beginning of the network, to the subsea pipeline network. Let's expand the network to new drilling locations not so far away. A production site may have multiple flow lines that are connected to more than one platform to increase production capacity. Or a flow line can connect directly to an onshore facility. In some cases, to save cost from building a new processing facility, a subsea tieback is used, which is a process that connects the new production site to an existing platform. Let's move on to the export pipelines. If each of those platforms has to build its own export pipelines to reach the onshore facilities, it could result in higher costs. Instead, there will be a main export pipeline, and each platform connects to it. Export pipelines not only transport oil to onshore facilities, they can also transport oil to FSO vessels and oil tankers. Transmission pipelines. Multiple lines from the starting points may merge into a single transmission line and then split into multiple lines to different destinations. Now you have an overview of the subsea pipeline network. Let's take a look at how they are installed. In the shallow water, human workers can be sent down, but in the deep sea, ROVs serve as workers. Subsea trees, manifolds, and other devices are laid down to the seabed using cranes. ROVs assist in precisely positioning these devices. The sizes of these devices are pretty big in reality. Jumpers are short pipes. They can also be laid down using cranes. ROVs plug in necessary cables. Before laying a very long pipeline, the seafloor needs to be scanned and analyzed. Not all the time the surface will be flat and easy, so to pick out the right path to lay the pipelines is important. Seabed preparation, such as trenching and rock placement. It is important to create a suitable surface to lay the pipes. This is similar to earthwork on land, except that this is under the water and has to be done by using different types of remote operated vehicles. There are three main methods of laying the pipes under the water. Tow-in installation for short pipe section. S-lay and J-lay methods are for laying a very long pipeline. Let's focus on the S-lay method in this animation. A long pipeline is formed by many shorter pipes welded together. For example, this pipe has a length of 12 meters and a diameter of 1 meter, made of steel and coated with reinforced concrete. So this is the actual color of the pipeline. Pipes are carefully welded together and covered to make sure there will be no chance for leakage. This is a pipe laying vessel. Pipes are produced onshore and loaded on the vessel. The supply ship constantly delivers more pipes. Each small pipe will be welded and then slowly dropped down to the seafloor. Once a pipe laying is started, the vessel has to keep continuing until the construction is finished, which means there would be no break in between even if it has to go through a storm. If the vessel is halting for too long, the pipeline might break and collapse because of the stretch. The touchdown point is near the other laid down pipe. The pipe will be measured and cut, and then be connected by using mechanical connectors or by underwater welding method. Umbilical cables are laid down by a ship with a giant spool. Pipeline is subjected to external damages and needed to be repaired. First, the pipe needs to be lifted by subsea cranes. Repair clamps will be installed and then drilled into the pipe. A bypass pipe is installed to redirect the flow of oil. The valves here will close to stop the flow of oil in the damaged section. The oil inside will be flushed out. The damaged section will then be renewed. After that, the valves open to let the oil flow normally again. Thank you for watching. If you have anything to add, please leave a comment below. My name is Lucis. I'll see you in the next video.